The next topic is utility theory. Now, this is based on the idea or the concept that monetary values don't have the same utility at all levels. Okay? In other words, a $1 is worth more when all you have, say for example, all you have is $10, then $1 has more value. Okay, then if you have $1,000,000, that one additional $1 does not mean the same to you as when you had only $10 in your pocket. So utility of monetary value is different from the bare bones monetary value itself. So when we do a decision analysis based solely on monetary values, we may be overlooking the actual utility of those decisions, and we may end up with subpar decisions. And this is fairly easily illustrated with insurance. Okay, insurance premiums, you don't mind paying the insurance premium because the utility of the loss that you may encounter is much more than the utility of the premiums that you pay. So because the premium you pay, you're never going to see unless there is a, a situation where you have to file for insurance claims. Okay, so now the problem is then how do you come up with a utility value for a monetary value? So monetary value is fairly easy. You just count the money, that's it. But how can you assign a utility value to a sum of money? So in our example, we had in our example for the plant example, so we had possible outcomes of 200,000 and minus 180,000 as two possible outcomes for construct large plant. So what is the utility of 200,000 and what is the utility of minus 180,000? It's very likely that this minus 180,000 has more negative utility than the positive utility of a larger number in dollar terms. Okay, and same here. So how do you convert these numbers into utility values? For that, we have to come up with some sort of objective utility scale, and that scale can be anything. It should have a smallest possible utility value and largest possible utility value. And the most logical, rational way of assigning utility is to simply use 0 to 1. So what you would do is you would assign the worst possible outcome with utility of 0. So in our example here, of all the possible outcomes, minus 180,000 is the worst possible outcome, and you will assign a utility value of 0 to it. And the best possible outcome, in this case best possible outcome is 200,000, then you assign a utility value of 1 to that amount. Now, so we're going to now compare that best and the worst possible outcomes with a certain monetary outcome. Okay, so if you're given a gamble of either you get this worst or best possible outcome, you may win or not win with these probabilities. Okay, the win probability is P, so lose probability is 1 minus P. And here you have a certain outcome. So at what value of P will you be indifferent between these two? And that P is then the utility of this dollar value. Okay, let's look at a numerical example. Suppose we have possible real estate investment opportunity, and the outcomes are either you make nothing or you make, say, $10,000. All right. So in that case, our worst outcome gets a utility of 0. The best outcome gets a utility of 1. So now we're going to have these two probabilities, right? Okay. And suppose our instead of investing in the real estate, so we put that money, that seed money that we have, say for example, let's assume that it was $5,000. Okay. Suppose if you have an opportunity keeping the $5,000 with you, all right, or you invest where you may lose everything or you may double the money. Okay. So you have the probabilities here. So now you start with probability of 0. Okay. Suppose if this probability is 0, which means you're never going to make $10,000, you're always going to make 0, then of course you're going to prefer $5,000. You take that money and you would not bother to take this gamble. On the other hand, if this is 1, then you will always choose the gamble. You will not put the money in the bank. So you will always choose that. So now somewhere between 0 and 1 for this probability, somewhere in between, you will find that you are indifferent between these two. For example, if you are a risk averse person, okay, then you probably would not settle for a p-value that is small. So you may want the probability of success to be as close to 1 as possible. If you're completely risk averse, of course, you're going to want p equal to 1, but most people are not that. So if you're risk averse but willing to take a little bit of risk, so maybe you would find 0.7 or 0.8 is an acceptable level of risk, and then you may say, all right, so that's when these two alternatives are, you're indifferent to these two alternatives. So in that case, utility for this $5,000 is 0.8. Another person may find that maybe a risk taker, maybe even p equal to 0.3 is a good deal for that person, in which case the utility of 5,000 will be 0.3 for that person. Okay, but let's stick with one person. Okay, so that one single person. So you for 5,000 now you've determined that the utility for $5,000 is 0.8. So now you try a different number. You try say 3,000. Okay, again, do the same routine. At what point in P these two alternatives you will be indifferent to these two alternatives. Okay, and hopefully here P is going to be even a larger value. I mean, you want P to because you're going to get only $3,000, so P will be a smaller value than 0.8. So you will settle for say maybe 0.5. Okay. And in this fashion, so you start with say 1,000 and then go 2,000 and 3,000 and 4,000 and so on, and you build a profile of the utility. Okay, so now you have from 0 to 10,000. Okay, you have 0, your utility is 0. For 10,000, utility is 1. So for each of the intermediate points, you pose yourself a wager like this, and then see at what value for P you will be indifferent. And so here, this is just an example. Suppose if for 3,000 you're indifferent at 0.5. So $3,000 utility is 0.5. Okay, 5,000 you are indifferent with 0.8 as the probability. So utility for 5,000 is 0.8. 7,000 you're indifferent with a probability of 0.9. Okay, so now you have developed a utility curve. Now given that these are all the possible values, you've already considered the worst and the best, right? So for each and every monetary value that you have to assess an utility for, you come to this graph, and then suppose you want for $6,000 you want the utility, so you go 6,000 and read the utility from this chart. So if you wanted to do utility analysis for the construction of big large plant, small plant, you would start with minus 180,000 all the way through 200,000. You'll construct the utility curve and then determine what the utilities are. So of course for these two it will be 0 and 1. You find the utility for minus 20,000, find the utility for 100,000, find the utility for 0. So now you have a utility table, not a monetary table. And then the analysis is exactly same like how you would do an analysis with monetary values. So instead of monetary values, you will have utility values. Now, a person who is indifferent to risk, all right, so that curve will be a 45-degree angle straight line. Risk avoiders utility curve will usually look something like that, and risk seeker utility curve would be